So this is our last section, 1.8 in chapter 1. So before we start talking about formulas, let's talk about what these words mean. What are we working with? So when we're talking, if we have a shape and we want to find the perimeter, what are we trying to figure out? We're finding the perimeter of a shape. Around, we're finding the distance around. So perimeter, we're thinking about the distance around and around the outside. So when we're talking about perimeter, that's what we mean. What about the area? What is the area talking about? How much space is inside? How much room is inside? The area is talking about the room or space. Inside. Perimeter is a length. We're talking about a length. When we talk about, and I forgot, this is for area. Area is the room or the space inside. So perimeter is a length. We're talking about inches, meters, yards. When we talk about area, how do we talk about area when we're using units? Volume would be for a three-dimensional shape, but I'm thinking when we say the area of this room is 25 square feet. So when we're talking about area, we're talking about square feet or square units. Perimeter is always a length, so just units, inches, yards, miles. Area is going to be square units, square feet, square inches, square yards. So for areas, we're going to come up with formulas. For perimeter, we could write formulas for our perimeters of our shape, but thinking about this idea, if we don't have to memorize formulas, I prefer not to have to memorize formulas. So if we have any kind of shape, what's the easiest, just bottom line, how do we find the perimeter of a shape? Just add up all the sides. So rather than writing down a bunch of formulas for perimeter, I'm just going to say for the perimeter of any shape, we just add up all the sides. Add up how far it is around it. So we're just adding up the distance around. That way we don't have to think about formulas for perimeters. Now sometimes the challenge is finding the lengths of the sides, but once we do that, we can find our perimeter. Now let's talk about our formulas for area. And these are all formulas that we should hopefully be familiar with. First shape is going to be a square. Let me draw a quick picture of a square here. So there's my square. What do we know about the sides of a square? They're all the same. So I'm going to mark these sides as all being congruent. And what do we know about the angles here in the square? 90 degrees. So all of these are 90-degree angles. We'll mark them as 90 degrees. So all the sides, the other way we can say that is perpendicular to each other. I'm going to call the side of the square, the length of the side, S. So that's how long the side is. S for side. How do we find the area of this square? What is it? Length times width, or base times height, something like that? Well, if this side is S, what is this side? S. So if we did length times width, what would we get? Area equals, I'm going to write it S times S, and we can write that as S squared. And our units for area are always going to be units squared. Now on the test, there'll be some area problems and some perimeter problems. We're going to ask you to use the units, because saying that something is 2 inches is different than saying that it's 2 square inches. So we want to make sure we're talking about the difference between area and perimeter. And then the perimeter, all we have to do to find the perimeter is add up all the sides of our square. So if we wanted to write our perimeter, what would our perimeter for this shape be? S plus S plus S plus S. And so how many S's do I have? 4. So our perimeter would be 4S. So 4 times the length of one side. So we're just adding up all the sides. Don't have to memorize it. Just remember we're just adding up all the sides. All right. We're good with a square. Something that we've seen before. How about a rectangle? So let me draw a rectangle here really quickly. There we are. Okay, so what do we know? Let's talk about the angles in the rectangle. What do we know about the angles in a rectangle? All 90 degrees. Just like a square. And what do we know about the sides of a rectangle? Top and bottom are congruent. So opposite sides are congruent. And let's call this side of the triangle, we'll call it B for base and H for height. So what's our area of a rectangle? Base times height. B times H. And our units are units squared. And I'm sorry, I should have written for perimeter. We just have units. So it would be inches, yards, feet, something. And our perimeter, we could write a formula for a perimeter. I'm just going to say add all the sides. So we have 2 of these and 2 of those, and we just add them all together. And our units are just going to be units. Perimeter is always a length. Inches, meters, miles. So squares and rectangles should be pretty familiar. So we have 2 more shapes to talk about. Triangle. Let me draw a triangle here. I'm going to don't want any specific kind, so I'm just going to draw a triangle. So this is just some random triangle. I'm going to call this side B, and I'm going to make a line, an imaginary line that makes a 90-degree angle with this side, and we'll call that H. So for a triangle, what's our formula for the area of a triangle? Base times height divided by 2. And that's units squared. And sometimes I will say base times height divided by 2 is fine. That's the same as saying 1/2 base times height. So sometimes I'll say 1/2 base times height. Means the same thing as base times height divided by 2. They're the same thing. And our perimeter, I'm not going to write a formula. All we need to know is we have to figure out the length of all the sides, and we're going to add all sides. And our units are just units. So again, a shape that we're familiar with, formula that we've used. And the last shape is a circle. And circles are kind of special. I want to make it a little bigger. So I'm going to draw a couple of pieces here for my circle. We're going to have a center, and I'm going to draw in a couple of lines. So what do we call that red line for a circle? Diameter. Diameter goes all the way across. So I'm going to call that. I'm going to draw an arrow to it. So that's the diameter. I'm going to label that D. And I'm going to do a line in blue. And what is that line? That's our radius. I'm going to call that R. Our area for a circle. What's the area of a circle? Pi r squared. First appearance by this lovely number pi. And our units are units squared. And for a circle, we don't really talk about the perimeter of a circle. We use a different word. What do we use for how far around the circle it is? The circumference. So we give it a special name. We have a formula for the circumference. Remember what the circumference of a circle is? What is it? It has pi times diameter. That first one's right. How are the diameter and the radius of a circle related? The radius is half the diameter. So if I wrote this, I can write our circumference in my units. If I wrote my circumference with radius, so I would write, how many radiuses does it take to make a diameter? 2. So I would write 2 pi r. 2 radiuses are the same as 1 diameter.
So you could do both.
You could do either one. Either one works. So sometimes the problem will give you the diameter and not the radius. Sometimes the problem will give you the radius and not the diameter. We can always get the diameter by multiplying the radius by 2, or get the radius by dividing the diameter in half. But for the area, we always have to use the radius. So that's our circumference, and that's the special word we use for the perimeter. We could ask, what's the perimeter of a circle? It's asking about the circumference. So I'm not going to do a lot of examples of calculating with the formulas. We should know how to use these. Most of the formulas are pretty easy. I want to do a couple of examples with circles, just to make sure, because there's something that comes up with circles, and do an example with a triangle where we have coordinates instead of lengths, and then talk about irregular shapes, so shapes that are not just one shape. So let's do a couple of examples with circles. So here's my circle, and here's my center, and I have this, and let's say this is 10 inches. And we want to find the area. So what do we need to do to find the area here? We need pi r squared. So we know our formula is area, I'm just going to write A for area, equals pi r squared. So what do we need to find out from our diagram? We need to find the radius. So what's the radius? 5 inches. We just divide this by 2. Radius equals 5. So now we can plug into our, and this should be inches, plug into our formula. So the area is pi times 5 squared. And it would be inches squared for my units. I'm going to show you 2 ways that you can do this problem, or 2 ways that you'll be asked this question. Sometimes the question asks you to leave your answer in terms of pi, or give an exact answer. When the problem does that, we leave pi sitting here and we just calculate with the numbers. So my area would be 25 pi inches squared. That would be our answer in terms of pi. We just leave the pi there and we don't multiply it out. The reason we do that is the symbol pi, what do we know that's special about pi if we write it out as a decimal? Keeps on going forever. So we're saying when we write this symbol pi that we're writing the number and all its infinite decimals. So we're saying this is all the numbers, all the decimals of pi, all written in that symbol. So we're saying 25 times that hugely long infinite decimal number. So this is in terms of pi, or an exact answer. If it says round to the 10th or round to the 1000th, then we are talking about an approximate answer. So then we plug that in our calculator and we calculate.
Is there a pi button?
Most calculators have a pi button. So I'm going to do 25 times, and I'll use the pi button on this calculator if I can find it. There it is. And I get about 78.54 square inches. So this would be my approximate answer, because I've multiplied this out and rounded it off. And if your calculator doesn't have a pi button, if you just use 3.14, that will be fine. Yes?
Which way should we write it? Should we write it like with the pi symbol, or?
If the problem doesn't ask you, then either one would be fine.
Okay.
If sometimes the problem will say leave your answer in terms of pi, and then I would be looking for this.
Okay.
If it says approximate, then I would be looking for that. So if it doesn't say either one, then then either one would be fine. Okay? All right. Let's look at one more example with a circle. Draw a picture here. And this is 7 feet. And we want the circumference. So I'm going to write C, and what's our formula for circumference? We can use 2 pi r, or pi times the diameter. We end up at the same place. So our radius, what's our radius here? 7, nice and easy. So our circumference would be 2 times pi times the radius. So if we wanted to leave our answer in terms of pi, how would I write that? What's the diameter? Or 2 times the radius? 14 pi. And that would be feet. So this would be my answer in terms of pi. If it wanted an approximate answer, I would multiply 14 times pi. So 14 times, and I'm going to use my pi button, and I get about 43.98. I'm going to put a little squiggly equals, which means approximate. So there's my approximate circumference. Questions on these 2 examples? All right. Let me ask you a question. I don't want to go through this one. I just want to ask how we would solve it. So what if I have this shape, and then inside here I have this, and we know this is 10 inches, and the radius of my circle is 2 inches. And the question asks us to find the area of this shaded part. How would we go about that?
Find the area of the square as a whole and the area of the circle as a whole, and then
Then we subtract. So we're going to find the area of the bigger shape, the square. So I can write this in symbols. If I would write this in symbols, I'm going to take the square, find the area of the square, and subtract the area of the circle. So the big shape minus the little shape, subtract the two areas. So it's like we're cutting that part out of the square. We're taking that away. So anytime you have a problem where you have one shape inside another shape, find the area of the bigger one, subtract the area of the smaller one to get the part that's in between. Subtracting is like cutting this out. So you'll have a few of those in your homework where it shows you shapes and it says what's the area of the shaded part. And the way I think of it is big minus small. Take the big area, subtract the small area, and you have the part that's in between. All right, let's look at using the formulas with coordinates. So sometimes you'll be given a problem, and I'm going to draw a triangle here. And maybe your triangle is on a graph. Oops, let me make that side straighter. There we go. This is a 90-degree angle, and let's say we're somewhere on a graph here. So we plotted points, each corner of the triangle on my x and y axis. And let's say the coordinates here, and I know my 0 is not going to be here, so we're on a graph somewhere. This is 2, -5. So this isn't 0, 0. I just drew that we're on a graph somewhere. This is -4, -5. And this is -4, 3 on my graph. And it wants the perimeter and the area of this triangle. How would we go about doing that? Let's break it down into pieces. Let's just look at this bottom side. How would we find, so to find the perimeter area, we need the length of the sides. We need the length of each of the sides. How would we find the length of this side? We could use a distance formula, but this is kind of nice because this is just like a number line. So the y coordinate here is -5, so this is going straight across. So what can I do to find my length of this? I can just count. So how far is it from -4 to 2? 6 units. So from -4 to 2, this side would be, and I'm going to write that in red because we figured that out, this is 6 units. So if we're going even with the x-axis or even with the y-axis, we can just count the spaces. I'll go over 1, 2, 3, 4, 5, 6 and get to 2. And because this is going straight up, I can do the same thing with this side. So how far is it from -5 to 3? 8. So this would be 8 units. Now for this slanted one, we can't just count. Then we have to use our distance formula. Use the distance formula that tells me the length of that side. So for this side, we're going to use distance formula. So if they're nice and they put your sides even with the x and the y axis, we can just count. The slanted ones, we have to use a distance formula. So let's label our points. I'll call this one x1, y1, and this one x2, y2. Doesn't matter which one we do, as long as we keep the 1s and the 2s together. And we'll find our distance. Distance equals the square root of x2 minus x1, 2 minus -4, squared plus y2 minus y1, -5, minus 3, squared. And now we just have to calculate, do a little figuring. Negative 2 minus negative 4 is 6. Net minus a negative makes it a positive. So we get 6 squared plus negative 5 minus 3, negative 8 squared. And 6 squared is 36. Negative 8 squared is 64. I shouldn't end up with any negatives under here after I square everything. So 36 plus 64 is 100. They made it nice and easy for us. Square root of 100 is 10. So this side is 10 units. So now we can figure out a perimeter. Just add up all the sides. 8 plus 10 is 18, plus 6 is 24. And our area, base times height divided by 2. What's our base of this triangle? 6. The height, 8 divided by 2, and I get 24 units squared. So sometimes we have to use our distance formula, or we have to use what we know about finding the length of segments to solve a problem that they might give us. Any questions on that example? All right, let's take a look at one last thing, irregular shapes. So irregular shapes are kind of like the shapes we made with that we did in our dot drawings, where they're made up of a bunch of little pieces. But all of our pieces are shapes that we already know about. So we're not making some crazy curvy shape. We're making shapes made of triangles and rectangles and that kind of thing. So our basic rule for irregular shapes is we're going to, kind of in an imaginary way, we're going to divide it and add. We're going to divide it into smaller shapes and add areas of the smaller shapes. So let's look at an example. I'm going to draw a picture here. So here's my shape. And my drawings are not necessarily to scale here. I'll try to make it as close as I can. Redo that one. We're saying all my angles are supposed to be 90 degrees. Okay? So there's my shape. I'm going to say this, this, and this. 8. And 12. And let's say that we're talking about inches and inches. And we want to find the area of this odd shape. So what we're going to do is try to divide it into smaller shapes and find the area of the smaller shapes. So let me draw in a dotted line here. What kind of shape is this? That turns that into a square. What do the marks on these sides mean? They're all 8 inches. They're all congruent. So that's 8 inches. That's 8 inches. And this is 8 inches. This little piece. So what's the area of the square? How do we find the area of a square? Base times height, and the base is 8 and the height is 8. So I have 8 times 8, which is 64 square inches. So the area of the square. Now I have this rectangle. But we only have the base, we don't know the height. Can we figure out the height? How high is this? 16, right? Because across this side, this whole side is 16, 8 plus 8. So this side has to be 16 also. Could we figure out how far, so then what is this length? 12, it's the same, this is a rectangle. So this whole side, if we needed it, we could figure out this whole side is 20 inches. So the area of the rectangle, and I'm just going to use abbreviation, rectangle, is, what's our formula? Area is base times height, and our base is 12, and our height is 16, and I multiply that out, and I get 192 inches squared. So the total $256, very nice, inches squared. So we just divide it up, figure out the parts that we need, and add up our small areas. If the problem had asked us to find our perimeter, how would I find my perimeter? Just add them up, add up all the sides. I have 16 here, I have 12 here, I have 8 here, 8 here, 8 here, 8 here, and 12 there. So I could add all of those up and find the perimeter. So that's how we deal with irregular shapes. Divide it up into smaller shapes that we know how to deal with. All right, questions? Okay. Hopefully this is more, nothing too new. All right, so let me stop this. I will